Welcome to Spring Lib.
Hey everyone, so what we have here is a rocket that is trying to land on the surface of the planet. What we're asked to solve for is to determine the flight speed it must have at A prime so that landing occurs at B, and we're also asked to determine the time it takes the rocket to land from A prime to B. We have to assume that the mass of the planet is 0.6 times of the Earth. And the way that we're going to be going about solving this problem is using our knowledge of orbital dynamics and using the relationships that we know for values at perigee and apogee, and also using the concepts of conservation of specific momentum and using that quantity to determine the period of our elliptical orbit. So let's go ahead and get started. What we can first do is use the relationship between apogee and perigee and say that RA is equal to RP divided by 2gm divided by RP VP squared minus 1. We can solve this equation for VP and see that VP is equal to 2 times the square root of 2gmRA all over RP times the quantity, RP plus RA. So what we can do now is determine this velocity at perigee, which is going to be our velocity B, that which the rocket has to have to land at B. So we can say that RP is going to be equal to 6 times 10 to the 6th, and RA is equal to 100 times 10 to the 6th. And these values are just pulled from our figure, and that VP is equal to VB. So plugging these values of RP and RA into our expression for VP, we see that VP, which is equal to VB, is equal to 8,674.17 meters per second. Next, what we can do is we can use the concept of conservation of specific momentum, H, and say that RP VB is equal to RA VA prime. And we can solve for VA prime, and we see that VA prime is equal to 521 meters per second. So here is our velocity at VA prime that must be attained to ensure landing at point B. Next, we're also asked to solve for the time required to travel from A prime to B, and we can first do that by solving for the period of that inner elliptic orbit. We know that this is equal to T, which is pi over H, times the quantity RP plus RA, times the square root of RP times RA. This gives us a total period of 156.7 times 10 to the third seconds. Now the time required to travel from A prime to B is simply going to be half this value. So T A prime to B will be equal to period over 2, which is equal to 21.8 hours. And that is our transit time, and that's our final answer.